Hello, and thank you for tuning in to Connections and Directions, our University of Michigan Civil and Environmental Engineering podcast. My name is Michelle Santillan, and I am the CEE Marketing Communications Specialist and host of this series. During our podcasts, we are featuring members of our CEE community and how their work reflects our mission of engineers in service to society. We will be highlighting our strategic directions and our commitment to diversity, equity, and inclusion. CEE's 5 strategic directions are human habitat experience, shaping resource flows, adaptation, automation, and smart infrastructure finance. Professor Joshua Jack comes to UMCEE from the Andlinger Center for Energy and Environment and the Civil and Environmental Engineering Department at Princeton University, where he was a postdoctoral research scholar. His current research focuses on energy and resource recovery as part of a sustainable water-energy-climate nexus, with a special focus on process design of bioelectrochemical technologies towards scalable CO2 valorization and advanced water treatment. Welcome, Professor Jack, and thank you for being with us today.
Thanks. It's great to be here.
What I'd like to do first is ask you to share with our listeners some details about your research area and goals and how they align with CEE's strategic directions and our mission of engineers in service to society.
Yeah, so after reviewing many different departments, I'm absolutely thrilled to be continuing my academic journey in the CE department at the University of Michigan. This is not just because of the amazing faculty and facilities, but because also my strong support of the goals outlined in the CE strategic directions and my dedication to the overall mission of engineering and service to society. Recently, it's become evident that issues including global climate change, increasing water scarcity, and rapid urbanization and population growth all pose huge environmental challenges that we must work together to tackle in the next century. Central to solving these issues is understanding and advancing our water, energy, climate nexus, which is really the cornerstone of my research. This includes developing transformative and disruptive technologies that can decarbonize our existing water, energy, and waste management sectors. This also includes developing new resource recovery tools that can help us reclaim valuable nutrients, energy, and water from environmental and chemical processes. Overall, these initiatives are really in line with the CEE strategic directions that note 2 important tools in addressing some of these impending environmental challenges will involve reshaping our resource flows and adapting to a changing environment. With these goals in mind, I've often thought about what our future would look like if we didn't have any pollution or waste, and how amazing that would be for our society and humankind as a whole. In the past, I've conducted interdisciplinary research to develop new CO2 valorization technologies that can help us directly leverage renewable electricity to redirect resource flows in a new circular economy. Through this work, I've developed interdisciplinary research expertise in areas such as electrochemistry, material science, microbiology, and engineering. Specifically, I've combined knowledge from each of these areas to develop multiple new hybrid electrochemical biological processes, which is a big word, but others also call them microbial electrochemical technologies. These devices can actually be used to upgrade waste like food waste, wastewater, sludge, and even CO2 into high value fuels and chemicals, while also recovering important resources like water, nutrients, and energy. At large, these hybrid electrochemical biological processes are really amazing because they can take advantage of both the high rates of electron transfer that you can achieve electrochemically, as well as the highly selective biosynthesis pathways offered by bacteria or enzymes. Overall, these devices have the potential to help us take materials that were previously classified as waste and repurpose them in other sectors of our economy. They can help us treat wastewaters and enable new desalination processes to combat water scarcity. They can even help us recover diverse nutrients like nitrogen and phosphorus from waste streams, or even help us capture and convert CO2 and turn into value-added chemicals, which has been the core of my research in the past. For example, while completing my doctoral degree at CU Boulder, I developed a new two-stage bioelectrochemical process that converted waste CO2 into syngas that was then fed to downstream bacteria and upgraded into value-added organics like ethanol and 2,3-BDO, which can be used as fuels. More recently, I actually built off this initial work during my postdoc at Princeton to develop a first-of-a-kind electroenzymatic process that uses enzymes to convert waste CO2 into precursors for high-value pharmaceuticals. So as you can see, these technologies can have an amazing value proposition as we're literally taking waste greenhouse gases and trying to turn them into life-saving medicines. As a new assistant professor, I plan to build on the success of these projects to close the current gap between research at the bench scale for these electrochemical biological processes and diverse environmental applications. At large, my group will bring together diverse researchers from different backgrounds to study new materials, catalytic mechanisms, and process designs that can support resource recovery and decarbonization of the water sector. This will really involve integrating new types of waste streams into these electrochemical processes and trying to remove emissions from our water sector as a whole. This will include different processes, including wastewater treatment, water reuse, waste valorization, remediation, desalination, and of course, carbon capture and utilization. In the near term, I hope to develop some integrated processes that can actually treat wastewater and simultaneously capture and convert CO2 while reclaiming nutrients from the wastewater itself. Through these types of projects, I see some really good opportunities to work within the CE department on topics such as wastewater treatment, biotechnology, remediation, and even data analytics. In the midterm, I'll be spending some more time looking at some of the fundamental aspects of carbon electron transfer that occurs at the abiotic-biotic interface, which will involve developing advanced materials and studying fundamental electrochemical processes, through which I see some great opportunities to really work closely with the chemical engineering and material science departments at as well as closely with others involved with initiatives such as the Graham Environmental Sustainability Institute and the Global CO2 Initiative there on UM's campus. And so building off of some of this initial work, I hope to progress these technologies and end up scaling them. So like, what's the point of making these technologies if we don't actually use them, right? So this will actually involve doing some techno-economic analyses and life cycle assessments to understand the socioeconomic benefits of our initial designs. In addition, my group will also be looking at developing some new machine learning tools and automation tools to effectively integrate these technologies with the related water and energy infrastructure. So overall, I think the culmination of my research can really have a profound effect on how society views and utilizes resources. And as a new professor, it is my goal to use this research to serve the common good and improve the human condition for as many people as possible. So I guess that's a good overview.
Could you give an example in what types of medicines or what types of diseases might be able to be controlled through some of these medicines that you're projecting?
Yeah, really, that study I discussed was a proof of concept where we first were trying to use CO2 as the feedstock to produce a class of lipid-lowering medication used to treat heart disease, which is called statins. And statins are actually amongst the most in demand and highest value class of pharmaceuticals around. So it's a great chemical to sort of open the door to this new idea of using CO2 as a feedstock to make a medicine. And so there's others that we're starting to explore, and hopefully as part of my initial research, we'll be expanding the portfolio of different pharmaceuticals we can make out of CO2.
What are some additional, if you wouldn't mind providing some additional details on things like the CO2 valorization and some other maybe specific examples of how you can bring those into consumer goods or other purposes that someone in layman's terms might be dealing with on a regular basis?
Yeah, so as we all know, I mean, there's a tons of CO2 up in the atmosphere, 3,200 gigatons. And so what we can do is try to use that as our low cost feedstock and actually use extract value from that waste source up in the atmosphere. We're really starting to just scratch the surface of the things that we can make. We can definitely start to target consumer products or precursors for those to make fuels. We can make pharmaceuticals, like I mentioned. We can make various solvents. One project I worked on was making isopropyl alcohol, which is in some of the hand sanitizers and things we use. So there's a whole range of different things we're starting to look at. but a lot of them are just the precursors to actually make chemicals that are the finished product for society. So we're working on expanding the portfolio currently, though.
So, how did you become interested in your area of study? Was there a course that you took or a personal
Hmm.
experience you had that led you to explore this topic in depth?
Yeah, I guess growing up in New York City, I was really fascinated by infrastructure and its relationship with the natural environment. And in college, I wanted to do something that I could, uh, have a direct improvement in the lives of other people. And I found with environmental engineering, I could directly improve the lives of other, delivering them clean water, air, soil, and energy. And so towards the end of college, I was really involved with the Engineers Without Borders. I'm sure a lot of you know of. And through several trips to places like Kenya and Nepal, I was able to see firsthand how environmental engineering could be really leveraged to make the world a better place. And after this, I started thinking deeply about some of the world's environmental issues and found that areas such as climate change, growing water scarcity, and increasing population and rapid urbanization might present some of the most challenging issues that we face today. And solving them could actually provide a huge benefit for the most amount of people possible. And so I started researching ways that we could alleviate these challenges by developing new technologies that can help us decarbonize various sectors and others that can upgrade different waste streams into value-added products, and even doing both at once. So related to these initiatives, I became really enthralled by the topic of environmental catalysis, as I've started calling it, which includes electrochemical, biological, photochemical, and thermochemical processes that we can use to directly exploit cheap renewable electricity to redirect resource flows in our society and perhaps even create a new circular carbon economy. And digging deeper into this, I found a great curiosity for these processes at a fundamental level, as well as the impact they could have in our society. So I'm really excited to continue my research very soon, as I have tons of scientific questions to address and a lot of new technologies I want to test out in the lab.
What classes do you anticipate teaching initially? And do you have ideas for additional courses that you would like to bring online down the road?
Yeah, so per some internal discussion, I plan to initially teach classes like CEE 592 on biological process engineering and CEE 482 582 on environmental microbiology. Overall, environmental biotechnology has been a common thread in my research, so these courses are really perfect for me to actually start off with. In the near future, I'd like to build off my expertise through research and actually offer a new graduate course on environmental electrochemistry, which we're still talking about. But in this course, I could envision us covering fundamental electrochemical topics and then expanding on that to actually see how electrochemistry rather can be used in renewable energy storage, carbon valorization, chemical synthesis, and other related environmental applications. In addition, I could envision this course covering topics related to microbial electrochemical technologies, which can be used in diverse areas such as wastewater treatment, water reuse, desalination, carbon capture and utilization, and even remediation. And so a little further down the road, it would be great to teach a separate class even on carbon capture and maybe call it environmental decarbonization, where we could look at the advances in carbon capture, utilization, and sequestration technologies as this space continues to evolve. And I think that would really give our students a broad kind of perspective of environmental engineering and allow them to think interdisciplinarily to solve these emerging challenges and even really start to think about how we can leverage some of these great advances in renewable energy technologies to treat different waste streams and be integrated in different environmental processes. So overall, it's really one of my goals to prepare our students to solve challenges that we don't know exist yet and hopefully turn them into independent and science literate thinkers. So I'm really excited to start teaching my first class soon at University of Michigan.
And how do you incorporate diversity, equity, and inclusion in your research and your courses?
Yeah, actually, coming from an underrepresented minority group in STEM, this is certainly a topic that hits home for me. Overall, I'm really dedicated to understanding and removing barriers that prevent underrepresented groups from reaching their full potential in science and engineering. In the past, I've been involved in advancing DEI through participation in groups and programs such as the NSF Teaching Fellowship that I had during my time in Colorado that aimed to improve participation from diverse groups in STEM. Another involvement I had was through the Colorado Diversity Initiative. They had a SMART program, they called it, where they provided mentors for undergraduate researchers from marginalized groups and tried to get them started in university level research. And then I've also been in clubs such as SHIP, the Black Student Union and Latino Princetonians here at Princeton. And so overall through these experiences, I found that the major pillars to create and sustain DEI in engineering include outreach, advancement, and community. And so while at UM, I hope to continue to be involved with advancing DEI on campus by engaging in events through the Center for Engineering Diversity and Outreach with programs like OnRamp, Next Prof, SHIP, as well as being involved with the CEE Diversity Committee. In addition to involvement with these groups, I plan on discussing case studies related to environmental justice surrounding climate change and equitable resource management in both my research and courses, and I've already been doing some research in this area. Overall, I hope to use my time at UM to continue to expand my skills and knowledge around DEI and work with other faculty to greatly advance DEI in the engineering community because I think it's a very important topic.
And is there a general message that you would like to convey to our UMCEE audience? Is there anything you'd like to add that perhaps I did not ask or address during our conversation?
Yeah, I guess so. The vision of the College of Engineering at the University of Michigan is to be the world's preeminent college serving the common good, which is a great goal that I really support. Through the research done in my group, I see immense opportunities to work together at the forefront of innovation to reshape our resource flows, decarbonize various sectors, and mitigate the impending impacts of climate change, which can really help our society as a whole. So while at UM, I hope to demonstrate leadership in these emerging spaces and use my research and teaching to make the world a better place. As such, I'd like to invite anybody listening to and who's interested in my work to please follow up with me via email, check out my publications. I'm actually looking to hire a few postdocs and PhD students very soon, so if you're interested, feel free to reach out. You can also follow me on Twitter at jjack.engineer. So you can find me there and connect with me there. I'll also have a personal website coming out relatively soon, as well as an academic webpage to give you some more information on my research and teaching. And so I encourage you all to check those out.
Well, thank you. We will. And we appreciate you spending time with us today in conversation. And we look forward to seeing you on campus. Thank you for listening to our podcast conversation. For more information about CEE at Michigan, please visit our website at cee.umich.edu. You can also reach our YouTube channel and Facebook, Twitter, Instagram, and LinkedIn pages from our website.